have our test on Tuesday. Wanted to try to get you a lot of the concepts that we have a strong feeling will be on the test. Guys, stop the chatter. This is your final DODIA test, not one that will be for grade. So what you know, look at all these key terms. This is why we wanted to make sure you guys have this. And we're actually going to get 2 different lessons today. So we're just going to do a real quick skim. We're not going to do any in-depth work on any of this, but we want to at least expose you to these terms so that hopefully at least a few of you will click when you see them on Tuesday. We're going to start by recognizing statistical questions and looking at variability, the 4 stages of the statistical process. We're going to talk about different types of data and how you collect, display, and analyze it. We're going to differentiate between surveys, observational studies, and experiments, methods for collecting data, and we're going to look at analyze and interpret bar graphs and circle graphs. Honestly, that's going to be a really short piece, but we are going to at least look at it. We do want you to be able to at least use a bar graph, so we're going to do a quick review on bar graphs. We're going to give you guys 2 minutes to figure out these couple questions.
How many students in the class play basketball? 12 students in the class play basketball. All right, how many students in the class play football? Why are you yelling? Not necessary. How many students are in the class altogether? 18.
Too many.
Big number.
30.
Oh. 36. No, it was just a question.
Anything.
Turn the page, please. You need your highlighter. You've got to be.
With our new mic, that shows up really nice. The rest of what's happening. So you guys are being recorded. We really need this to be as clean as possible for everybody else. Okay, starting on, we're going to have a lot of highlighter today, guys. So our first part, we're going to talk about the statistical process. The statistical process has 4 components. This is formulating a statistical question, collecting appropriate data, analyzing the data graphically and numerically, and interpreting the results of the analysis. In statistics, variability means that the value of the attribute you're studying can change from one person or thing to another. That is a key piece in doing statistics. If there's no variability, that's not statistical. A statistical question, which is basically the whole impetus behind the statistical process, is a question that anticipates an answer based on data that vary. And I'm actually going to add, normally we just highlight, but I'm going to add a circle to this, because this is the most important part of a statistical question. It must vary. If the data doesn't vary, it's not a statistical question. So if I say, how tall am I? Is that a statistical question? No. I am one height. Anybody in this room that measures my height should get the same answer.
How tall am I? What is that?
Now, if I change it and say, what is the average height of a 6th grader? Is that going to change? If I measure all of you, are you all going to have the same height? No. So the fact that I'm asking about the average height, that is going to change based on the data I collect. And we'll talk about that in a little bit, in just a little bit. So realize the data varies because I now have taken it from I, which is a one person that's not going to vary, to the sixth grader. Okay? Yes.
Wouldn't the average be one answer?
But the data itself is going to change. But if I could say, what is the height of a sixth grader, that would be an even better statistical question. But your average is going to based on your population, which we'll talk about. Those are some more terms we'll talk about in a little bit. Okay, so we're going to look at two questions, Bianca and Rajan. We want you to tell us why they're not statistical. We're telling you they are not, and why his are. And then what kinds of answers do you expect from Rajan's questions? So we want you to talk as a table group on this one. We'll give you guys about 2 minutes to answer these questions.
Why aren't Bianca's questions statistical questions?
Because you are, which is regarding to herself, and margins are correct because he's talking about everything. So meaning it's different people, so it's the different answers.
Okay. Okay. Anybody have different? Damien?
There's only one answer.
They said that. Anything else? So, Bianca is only talking about one person or one club. So if she's only talking about one person or one club, there will only be Rajan is talking about multiple clubs and multiple people. So we'll have what? All right, number 2. What kinds of answers do you expect from Rajan's question? They need examples.
Examples,
Like the number of.
like how many, like,
Say that again.
oh, writing club and the extra girls.
She says writing club, excellent club. We could do gaming club. Those are some answers, yes? There's more, but those are examples. What about his next question? What could some of the answers be? I doubt it.
Like, like 23.
23,
22,
22, 15, 18, 7. Any of those could be an answer for how many people are in a club, yes? Any questions about this? All right, you need your highlighter again for this vocabulary word to decide. Data. The data are categories, numbers, or observations that is gathered from a statistical question. It is the answers you get when you ask a question. That is data that you are gathering. Any questions about that? Yes. Next page, please. I don't know what you did on this page.
Hey guys, on this one. So we're going to skip that first part. We've got two more definitions we need though. So categorical data or qualitative data fit into exactly one of several different groups or categories. So when I'm looking at categorical data, I'm basically saying, how often does this happen? Okay? So categorical data is stuff like, what's your favorite sport? Okay? So do I have a solid number? Is basketball represented by a number? No. But can I count how many people like basketball?
Yeah.
Yes. So that's what makes it categorical data, because the data itself is categorical. But if I ask you, what is your height?
Oh, 5 foot.
Is that a category?
No.
No, it's a number.
Yeah.
You see the difference?
Yeah.
Okay? So if I'm talking about your height, now we're doing quantitative data, or numeric data is based on a numeric scale and complete. So I can still count how many there are, but what I'm looking at is different based on how I'm phrasing my question. So my favorite sport, that's categorical. What is your sport? Height is giving you a number. That's numerical. Make sense?
Yeah.
Can you see the difference? Categorical is just saying it fits into categories. So football, basketball, soccer, tennis. The clubs, military history, gaming club, STAR, Lego, robotics club. They're different names. So a good way to think about a category is names. Numeric or quantitative is actual measurements, actual numbers. Okay? Okay, we didn't quite have enough time last class, so I'm going to skip that part of it. But we do want to come to this. We do want you, based on the statistical questions you just asked on the previous page, or the data you looked at on the last page, write 3 statistical questions you're going to ask about school lunches. So if I'm going to collect data about school lunches, give me 3 statistical questions that I could ask about school lunches. We'll give you guys about 4 minutes to work as a group and come up with 3. So your whole group can have the same 3. We just want to make sure each.
Who can give me a statistical question about lunch? Would that give you more than one answer?
No.
If you specifically say in a month,
No.
we could look at the calendar for lunch and we would get how many answers. So is that a statistical question?
No.
Lower your voices, please. Ellie? Can you make it more specific so it is a statistical question? Davian?
How many people like pizza?
Would that give you more than one answer?
Yeah.
They either yes they do or no they don't.
Only one. Right school lunches on the side.
Hold please. Guys, I can't hear what he's saying because you're talking.
Rank school lunches on a scale of 1 to 10.
That's not a question though.
How many people eat pizza burgers?
Can you make it more specific where it would have more than one answer? Yeah.
How many people eat
Would that give you more than one answer?
I'm not supposed to. What is the amount?
School lunch daily. Do you think the same number of people eat school lunch every day?
No.
No, because somebody might be here on Monday, but they're not here on Tuesday. So are they going to have the same number?
No.
No, so that is a statistical question.
Oh, yeah.
That's important. To add that little piece makes it a statistical question. All right, who can give me another one? Frank?
stop background chatters.
Please. Well, it's basically the same question.
Oh wait, how many students enjoy home lunch over school lunch session?
That would only be one answer unless you made it more specific.
How many is lunch evidence if you want Aaron to do it?
Well, no, because A lunch would have an answer and B lunch would have an answer, yes? So how many lunch monitors
I got
For lunch.
are needed for each lunch each day?
Oh. That's what better way than what?
All right, I'm gonna write my question.
Oh, okay.
What is the student's favorite lunch? Would that get the same one answer? Do you think everybody's favorite lunch is the day you have breadsticks and some kind of sauce to dip it in? No, that is not everybody's favorite lunch. So you will get more than one answer. I do not like talking over people. All right, you need your highlighter again, please.
On this one, we've got a couple more definitions for you. And this is kind of hitting back to what we talked about in that initial piece. And that is, where are you getting your data from? There's two major terms we use when we're talking about where we're getting our data. The population is an entire set of items from which you collect the data. A sample is a selection from a population. So the population is the big overarching one. So if I talk about an answer for a population of all sixth graders, and I didn't put any limits on that, I would then need to basically survey every single sixth grader in the entire world. That would be your population. The way this is stated, it says, if I'm looking at the population of sixth graders, population of all sixth graders, I need to determine the heights of every sixth grader in the world. But to answer the question, using a sample of sixth graders, I can collect data from just the sixth graders at my school. Or I can get even more specific. If I wanted to talk about an average height, I could just say the sixth graders in our math class for A4. Then it would just be you guys. So that would be even a subset of the data. So your population is the big group that you're looking at. The sample is what data you're actually looking at. That makes sense for everyone. Okay? So they're very closely related. Your population is just your bigger group. The sample is what you're specifically looking at. Okay. Now we've got a few more terms. Like I said at the beginning, you need a lot of highlighters today. You're using your highlighters a lot. When we are looking for data, there's three primary ways we can collect the data. We can do a survey. In a survey, you can ask people one or more questions. You can do an observational study. And in this one, the researcher collects data by observing the variable of interest. In other words, you're going to look at something specific. In an experiment, the researcher imposes a condition and observes the results. So a lot of people get confused between the observational study and the experiment. In both of them, I'm actually watching for data, but in the experiment, I've put limitations. Okay? So in the observational study, that would be like, Isaiah, you got a question? No? Okay, so you could conduct an experiment to investigate whether sixth graders perform better on an assessment when they read a textbook or watch a video. You could randomly assign half of the students to read the text, the other half would watch the video, and then you give them the same test. And you see which one, by comparing the scores, would have the actual data. So now we're going to go back to the questions that you guys just wrote. We want you to identify the population and sample of interest, and then state whether you use a survey, observational study, or experiment to collect the data to answer your statistical question. So everybody should at this point have 3 questions from your table group. Go back through them. Tell me what's your population and how are you going to get your data. Okay? We'll give you guys about 5 minutes to work through this one.
All right, the first question was how many students eat lunch each day? What is our population?
Every the entire school.
The entire school, the students at KMS, yes?
Yes.
All students at KMS. What is my sample? Who am I going to talk to or observe? Do I want to ask 567 students? Do I want to take the time to do that?
No.
No. So I need a smaller part of the population. What could it be? You're talking about students.
Favorite teacher?
You're talking about students.
Oh.
A-Lunch.
Somebody said it.
A-Lunch.
You can do 6th graders. All 6th graders. You can do A-Lunch. That's fine as well. And how are we going to collect our data? What are we going to do to see how many people eat lunch? Survey, observe, or what was the other one? Experiment. Observe. Okay, this one could be observation.
Why is it observation?
It could be either one.
There's no right or wrong answer.
Experiment would be the wrong answer.
Observation.
Those are both right. All right, B. I do not like talking over people, and it's on my side of the room. Stop. Our second question was how many lunch monitors are needed for each lunch each day? So, what is our population? All lunch monitors. What is my sample?
A, B, and C. That you said each lunch.
But that would be all lunch monitors. That's our population. What is our sample? Okay, just a lunch. A lunch monitors. And we could do that each day of the week, yes? And what are we doing to collect our data? Observation. That's a good one. And the last question said, what is each student's favorite lunch? So what is our population?
All students at KMS.
All students at KMS. All right, what is my sample? We did 6th graders, so what could this one be? It could be 7th graders, it could be B lunch students. And how are we going to collect our data? Not if you're trying to find out what their favorite lunch is. What do you think? You're going to do a survey. You're going to ask them. Any questions about that? All right, let's look at the next page. You're going to need your highlighter again.
Okay, guys, on this one, when we're looking at data, we're into step 3 where we're analyzing the collected data. In order to analyze it, we need to be able to see our data. So we've got a couple primary ways that we use them. A really popular one is a bar graph. Bar graph uses categorical data, meaning it's going to be in categories. So we're looking at names of different things, using either horizontal or vertical bars on a graph. The height or length of each bar indicates the value for that category. So the more data there is that fits that category, the larger that bar is going to be. In a circle graph, we also commonly call that a pie chart. Displays categorical data again, but now it uses sectors or wedges of a circle. It shows how parts of the whole relate to the whole and how parts of the whole relate to the other parts. So showing you individually this piece of the whole, but then you can also use it to compare the different parts by how big each of the different parts are. So the area of each sector corresponds to the ratio of the part in relation to the whole. So your pie chart is based on ratio. A bar graph is literally just this is how much data there is. So you can see it laid out a little more clearly in a bar graph than in a pie chart. Excuse me. So just help you guys see this. We've got a couple examples. Nicole and Neil looked at favorite sports. They surveyed 30 students in their class. Then they displayed their class's data in different ways. We want you guys to take a look. Nicole used a pie chart or a circle graph, and Neil used a bar graph. So one big key on your bar graph, you'll notice the categorical data. The categorical data, the categories they answered in, gives me what I'm putting on that bottom axis. My number of responses is what makes my other axis. That's how far up it's going. So we want you to take a look. How are the graphs similar and how are they different? So we'll give you guys about 2 minutes to discuss it as a table group. Look for any differences, look for any similarities between the two.
Fuller. Rain? Pause for a second. I'll wait till you're done talking so we can actually hear what she's saying. Try again.
Both show the same story.
Okay, both show
Well, the same kind of.
the same categories. Okay. Answer?
I have a stupid one, but they both have the same title.
Okay. They're both showing us people's favorite sports. Fabian?
They're like different parts. They have.
Right now we're doing similar.
Oh.
What can you see when you look at both of them?
They both give the same information.
Not necessarily. One of them has numbers and one of them does not. So that's not the same. But what can you tell?
They both have smaller and bigger amounts.
And you can tell what by that?
Basketball's most popular, wrestling please.
That's what I wanted. Both show that basketball is most popular. And wrestling is least popular. All right, now, how are they different? London? Okay, one's a circle graph or a pie chart, and one is a bar graph. All right, how are they different? Which one? The circle or the bar? The bar graph gives numerical data, meaning it tells you something in numbers. Yes?
Yes.
Anything else? That's a good observation. I hadn't heard that one yet. The pie chart shows what part of the whole likes each sport. Avian?
So like it shows like what the majority is and like the
Well, we already said that both show us basketball is most popular and wrestling is least popular.
and then that's how it's
Okay.
like the chart the pie chart shows the majority and like the other chart shows
Okay, I'm not sure how to write that though. Ellie? They're both correct? Okay. Can we get information from both of them? Yes. Can we get the same information from both of them?
No.
Oh, one of them gives us numbers and one of them does not, right? So yes, I can see which one was most popular, but can I tell you by how many? No, not on both of them, only on the bar graph. Any questions? All right, next page.
Again, this one, we're going to talk, and this is where it gets, again, a little nitpicky. We want to make sure you guys understand the vocabulary. So when we're looking at data, there's two major terms we're going to use. We can talk about frequency. Frequency is the number of times an item or number occurs in a data set. Okay? So when we just did our survey, we said in football, that showed up 4 times. So that's its frequency. Does that make sense? Okay. Once your frequency is known, then I can determine one of our measures of central tendency, which is mode. Mode is the value or values that occur most frequently in a data set. I'm going to add to this definition because there's a piece that they're missing that is really critical, and that is how many there may be. There may be no mode. Or there may be more than one mode. We'll talk about it in a second. For right now, just write it down. Okay? And here's where this starts to get tricky, is when we start talking about the difference between frequency and mode. So we've given you an entire set of data, yes? So what would be the mode of this data? How did you get that? Isn't 7 the biggest number? To make sure they understand the confusion point. Awesome. Well done, Asher.
5.
Yes, you are absolutely correct. Unfortunately, a lot of students would immediately say 7. Is 7 the mode? No, it's the highest data point, but that is not the mode. The mode is which one shows up most frequently. Asher went through and he said, hey, wait, the 3 shows up 3 different times. So that means that the mode of this data is 3. It's the one that shows up the most often. Now here's where it gets a little more confusing. Had there been 2 people who liked wrestling instead of just 1, then we would have 2 modes. Because how many times would 2 have shown up? 3. So in that case, I would have two modes. 2 and 3 would both be modes. Does that make sense? Because they both, and here's the key, they both showed up more than once, but then they showed up the same amount of times, which was the most that any data showed up. So if all of the data points only showed up once, there would be no mode. Okay? So if each data point was unique and individual, there's no mode in it. If I have the same for two or more, there could be multiple modes. Yes. What about one? If all of them show up once, there's no mode. David? Like this? If there was no mode, then every number would be different. How would I write it? Once I change that 1 to a 2 and now I have 2 modes, you would write mode is 2, 3. So you just show that there's 2 modes. It will be. Okay, excuse me. So that's all. This was the biggest piece we needed on this page. We're going to take a jump because we've got some more pieces we need to talk about. So go ahead and turn over to page 632. Ashley, you got a question? 632.
You wrote down
Could have, but we normally list them quickly. So I'll put the lower one and the higher one. Okay, guys, really quickly. We're going to talk about some of the ways that we display data. Right now, we're going to talk about dot plots. Mr. Nicholas poses the question, which grade has the fastest average rock climbing time if each student attempts one climb? Let me start with what we've just been talking about. Is that a statistical question?
Yeah.
Why? Which grade has the fastest average rock climbing time if each student attempts one climb?
Oh, yeah.
Is that a statistical question?
No.
It's not a great statistical question, but are my times going to be different if every student attempts one climb?
Yeah.
So will my data vary?
Yeah.
Yeah, so that makes it a statistical question. The way you phrased it, I don't like, because a lot of you said, wait, which grade has the fastest? There's only be one answer, right? So is it a great statistical question? I would say no. I would call it a statistical question because they put rock climbing, each student has one climb. So we're getting a bunch of data that's going to vary. Okay? So that's where the whole statistical question piece gets a little complex. So we've given you 3 sets of data. We want you guys to take a quick look. How are they similar? How are they different? And what can you observe from the data, looking at the charts that you can't see from the plain data? Okay, how are they displayed similar? Max? Oh, technically.
Five.
Oh, they're all 50 or 60.
No,
40. So they're all
48.
48's like,
40.
No.
yeah, no.
They're all within that.
Well, they have number.
What else do you have? Asher? Good. They're all in seconds. So they use the same measurement. What about differences? You guys see differences? The mode. Okay. So what is our mode?
50.
So actually, let's look real quick. What is our mode for the
16. 16. 16. 16.
only one answer?
60.
60.
Thirty-six.
No, it's not.
It's 60.
It's 55. What's the answer, guys?
I don't think it's not.
It is 60. What is you see most often? 60. 60 has the most.
No, it's not 60.
Wait, Bob, you missed it? Right. More than one. That has to.
Oh, wait.
Four. One that has the most data sets. How many showed up twice? These all showed up once. They can't be modes. This one showed up 4, 3, and 5.
54 and 60.
54 and 6, or 54, 57, sorry.
Wait, how is it 54?
Good. They both showed up twice, yeah? What's the frequency of them? Which one? Those two showed up twice. 2 was my most common. 60 was the highest. The ones that showed up the most commonly, 2 data, 2 points, and 54 and 57. Remember, your mode is how many times does it show up? Not what's the biggest.
60 shows up 5 times.
Yes.
But 54 and 7.
Are each twice.
Yeah, but then I'll do 4.
But they each show up twice. If we put numbers to it, how many times did 50 show up? Once. Okay? On this one, we actually have one mode because there's 3 that show up 5 times. Okay, let's go to our next page, guys. We got a lot more definition we need to get in. Actually, stuff on this page. Skip this for time's sake. Dot plot. Going to page 634. Page 634. Guys, page 634. The dot plot is a data set, a data display that shows discrete data on a number line with dots, X's, or other symbols. Dot plots help organize and display a small number of data points. Guys, dot plots are only going to work if you have a small set of data. If I'm looking at hundreds or thousands of pieces of data, I'm not using a dot plot. In those cases, a bar graph is going to be a far better way to do it. The dot plots work really well for small pieces of data because it helps you to really visualize how the data is laid out. So we're going to go through these really quickly. What do the 2 X's above the number 14 represent? So if I look at 14, there's 2 X's here. What does that mean?
The number
Evan?
the number of countries that won that.
How many? 2.
Wait, what?
So 2 countries
What?
won 14 medals.
Wait, what did
The X's represent the number of countries
Oh,
that won 14 medals. So with those 2 X's, it's saying there's 2 countries that won 14. And what do the 6 X's above the number 1 represent?
6 1
6 countries won 1 medal. Okay? Why are there no X's above the number 4? Why is there a blank spot here? Reverse that. 0 countries won 4 medals. So, no countries 1, 4 metals. So there's no data points there. So if there's no data points, I don't put an X there. Okay, if I use my dot plot to determine the number of countries that won medals in the 2018 Olympics, how could I use this to figure out what my total was?
You add all the X's.
Count all the dots or all the X's. Don't tell me how many countries won medals. Why is there nothing above 0? Does that mean every country that went to the Olympics won a medal? No. It's because what is our data? Total medals. So if I didn't win a medal, does that count as a total? No. So it's only looking at those countries that actually won. That's why there's nothing above the 0. Otherwise, that would have been a little bit higher. Okay, here's another huge piece of it. We're going to talk about distribution. So this is another one of your terms. Distribution. The overall shape of a graph is that distribution. The way the data spreads out is what we call their distribution. There are 3 primary distributions we're going to look at. You have a symmetric distribution. That means the peak of the data is in the middle. The left and right halves are mirror images, or at least relatively close. If it is skewed right, the peak of the data is to the left side, and there's only a few data points to the right. So when it's skewed right, you kind of think about that's how it slopes. It's sloping down to the right. So if it's skewed right, it's sloping to the right. There's less data. Skewed left means the peak of the data is the right side of the graph. There are only a few data points to the left side. So skewed left means my slope is going down to the left. So if I'm left on the left, it's skewed left. Everybody understand those data pieces? Okay, so being able to understand what my data looks like helps you analyze the data, because it's going to throw off some of your averages depending on how your data looks like. The data that we hope for, if we have a good statistical question, is our symmetric. That's really what we're hoping our data looks like. That normally means you have a good set of data. If your data is skewed one way or the other, it means there's normally something wrong with your collection methods or the question itself, that you're not getting a true center in your data. Doesn't mean it's bad, it's just that's not the ideal. So Miko looks at the dot plot and says it is skewed right. Do you agree with her?
Yeah.
Yes.
Yeah.
The way we look at it, kind of just like they did, you draw a line over the majority of the data. So it kind of goes across the top. Which shape does that look like? Skewed right. So is she right?
Yeah.
Yes.
Makes sense. Good. Okay, our next one. Here is a major piece we like to talk about when we're discussing data, and that is going to be how is it associated? There's a few terms we look at. Clusters are areas where data group close together. Gaps are areas where there are no data. Pigs are values that contain more data points than the values on either side of it. Outliers are data values that lie a large distance from the other data. Outliers usually accompany gaps in data. It is possible, if you've got a couple of data points that are way outside of everything else, that they're both outliers, and there are statistical methods to figure those out that we're not going to get that deep into. For now, we're just going to use the eye test and say, does it look like it's pretty far away from the data? If it is, we'll call it an outlier. So as we look at it, if we look at this data set, and here's one of the ironies in this, there's not technically a really correct answer. There's several ways you could view this. The way I would view it, I would say we have a cluster here. You have a cluster here. And I would even almost say you have another cluster out here. Okay? The pieces in between, these are what we call gaps. So you have a gap here, you have a gap here, and that's where these two kind of get a little bit odd. You can put them in with this cluster, which is probably what I would do if I were looking at this actual data. This one that's out here all by itself, he is what we call an outlier.
What country was that?
Okay? Actually, in this one, it was Norway.
Oh, wow.
Yeah, Norway, the Baltic countries do really well at the winter sports. Your peak is going to be right here. That's the largest piece in the data set. The problem with these two clusters is you don't really have a peak because they're all the same. And that's why you may not call them clusters, and where we get a little bit off on some of this. But you should be able to get the general idea. Clusters are the data that's together, gaps are the spots between, peaks are where it's really high. Okay, we got a few minutes left. We got one more thing we need to go through, and that is a stem and leaf plot. In your stem and leaf plot, this is another graphical method used to represent ordered numeric data. When we're doing a stem and leaf plot, the stems and the leaves are the two pieces. The stem is all the digits in a number except the rightmost digit, which is the leaf. Okay? So for data that have only a ones place, the stem would be 0. So in this case, and your key is always going to kind of help you on this, it's going to show you what your stem and what your leaf is. So the parts that are to the left of the bar, this is your stems. There we go.
That's the stem.
That's the stem. All the little numbers, these are your leaves. So what this is saying is, if your key tells you a 4 out here with the 1 on the inside means that that's 41. 41. So the 4 and the 1 represents the data set of 41.
What about 56?
Okay? So all of these means 0, 5, that's one data set of 5. 0, 5 means it's another data set of 5. 0, 5 means it's another data set of 5. So there's 3 different countries that won 5 medals. Do you see how there's 3 0, 5s? 0 is my stem. So all these numbers have a 0 in front of it. 1 is my stem, so all those numbers have a 1 in front of it.
So it's 10, 10, 10, 11, 11.
Yeah.
So 22.
There you go. You're seeing it.
41, 22.
Yeah. So the largest number of medals won was 121. Okay? Guys, homework tonight is just math, yeah. But you're going to be seeing all these on your quiz test next week. So. Okay, guys, everyone left, but I just wanted to point out real quick again, we're looking at a stem and leaf plot. All you're going to do is look at each line and figure out which number appears the most often. So for the zeros, we have 5 8s that show up. And the 10s line, we have 5 11s that show up. So this is another data set. We would have 2 modes. So your modes are 8 and 11. So because this 1 is part of the number, you need to make sure you include it. I do want to go back and apologize to Mr. Chan for any of you that listen to the video. So we're looking at this. Where was it? This data set. The mode actually was 60. I was looking at for how often it appeared. There were 2 data sets that had that, but the one that showed up the most often is 60. So your mode actually would have been 60 on this one. And this is actually a good example of why mode is not necessarily a good indicator of the center of the data, because that's at the very end. So your other measures of data would actually be considerably less than that. Good luck on your test, guys. I hope this helps everybody get ready, and we'll talk to you soon.